All right. We've done a couple of videos up to this point about how to use different functions in R and how to do some math. But I received a couple of questions recently about how to not necessarily code, but how to get mathematical equations to show up in R. So this is not something that I expect anyone to have to use. This is a purely optional video of people who are interested in writing mathematical equations to look more standard in R. This is not something we do in the code. This is something we would just do in the writing. So normally where I might say, if I was answering a problem and I said, if we know that the that probability of A, let's say equals 0.4, and that probability of B equals 0.5, and that the probability of B given A equals 0.2, then we can calculate probability of A and B with the general multiplication rule, right? So I could write that, and that is a totally fine and how I expect you guys to write stuff in lab. If I go ahead and knit that, it will come up and run its stuff, and it looks fine. It is readable. We have code underneath there for running it that I had not done, but I can read that. But if I wanted these equations to look more like equations, what I can do is use LaTeX. LaTeX is just a language for writing math. If you want to learn more about it, look it up. It's LaTeX. Just make sure you search something like how to write LaTeX equations. And don't be like me when you're doing your master's on a United States Air Force base and Googled just LaTeX from a government computer, because that search is something different. But what we do is, for R to know that we are doing it, we use a $sign. So when I put a $sign around something, it now knows that that is an equation. And so now that is what it's going to look like. And it is just going to look more like an equation. For things like this, where there is not any special characters in there, it just, all it does is kind of turn it into a math font. By mousing over, I can see what the particular equations look like. I'm going to put it around here as well. And get that. Now, when I get over here, it gets a little more complicated, right? Because when I put $signs around this, it just is going to say and is like it's a mathematical thing, and it ignores spaces in there, right? And so this is where it becomes a little more specific. If you want to put in symbols, you need to know the terms for it. There is almost an infinite number of terms here, so I'm only going to show you a couple that might come up here more often than not. When we want the intersection, whenever we want to give a special term, we put a backslash in here. And so the and is called a cap. And you can see as soon as it recognizes it, now it looks like a cap. If I'm doing the general multiplication rule, now I can go ahead and say, in my equation here, this is going to be the probability of A cap B equals the probability of A, and then I'm going to say times. And I could put asterisks, but if I say backslash times, then it actually gives me that multiplication symbol, times the probability of B given A, right? And that's just the same symbol. It just makes it look a little nicer. And so I can go ahead and write that in, and then when I knit the document, it will look like that. Some other things that come up besides the intersection. We might be interested in the union, right? And the union is very similar. So if I said the probability of A instead of cap, it is a cup. So we're going to say cup B, and there is the probability of that. Another thing that we might be interested in is, let's say, we might be interested in Greek letters, right? And so we know that the variance of x is equal to sigma squared. Well, all the Greek letters are just the letters with a backslash in front of them, sigma, and then it brings, if I put a capital S sigma, it would have given me a capital sigma. If I want to square it, I should have said this is Greek letters and exponents. Then I just use the above the number 6, the little caret, and then I say squared, and that puts it in the exponent. Another thing that comes up are subscripts, right? These are things like, if I want to have a bunch of different x's, I could say x, and then I use _1, and that makes a subscript. X _2, I could say x _ n. If I want to put more than one letter down there, then I have to say x _, and then I use the little curly braces and say n+1. And now you, whoops, I did a parenthesis instead of a brace, and then it's got the n+1 down there. The last thing is fractions, which sounds simple enough, but we actually have a term for that. It is, or a code in here. It's the \frac, and then I put what I want on top, and then another brace of what I want on the bottom, and you see it pops up. Now, you could just easily write 1/2, but the nice thing about this fraction is that I can then put anything in these braces like equations. So I could say 1 plus x raised to the 2 up here, and then down on the bottom, 2 minus y _2, like that. And you see it updates as they go. And then the nice thing is when I knit this, I can see now that as it comes up, it runs all of my equations. And then I can use this to go in between explaining what I'm doing to then doing the code of what I'm doing. So like I said, this is a very small subset of what kind of things you can do with the equations. And if you're interested more, if you're looking for something specific, you can always ask me or else look up LaTeX. But again, this is completely optional. Writing it in just straight text form is totally fine, and the instructors will not grade you down for it. But this was a request by several people, so I wanted to post it up there. I hope it is helpful for the people who wanted it. And for the rest of you, I will see you guys in the next video. Thank you for joining us.